Welcome back to our topic on longitude and latitude, and in this lesson we look at the distance on the Earth's surface. The radius of the Earth is taken to be 6,370 kilometers, and pi will be taken as 22/7 unless otherwise advised. Now, the distance on the Earth's surface involves arc length, which we have already covered in the previous lessons. And it also involves the angle subtended by the arc at the center of a given circle. So what is important for us now we'll be able to determine, is the arc length on a great circle or is it on a small circle? We'll look at this diagram which will represent the Earth, and let us take points D, E, F. Points D, E, F lie on the equator. Point D also lies on the 40 degrees east longitude. Point E also lies on the prime meridian 0 degrees. Point F lies on the 20 degrees west longitude. Let's now consider arc length DE. Arc length DE. Arc length DE subtends an angle back there. Arc length DE subtends an angle of 40 degrees because it lies on the 40 degrees east from the prime meridian. This is what we mean by 40 degrees. And therefore, coming back here, arc length DE will be the angle it subtends at the center over 360 times 2 times 22/7 times the radius of the Earth, 6370, because it lies on the equator, which is a great circle. So the distance on the Earth's surface from D to E is this one. Going back to the diagram, let's look at arc length EF. Arc length EF again lies on the equator, but the angle subtended by arc length EF is from 0 to 20 because it lies on the 20 degrees west. So the angle subtended by EF is 20 degrees, and therefore arc length EF will be 20/360 times 2 times 22/7 times 6370. All right, let us now look at DF. DF. Arc length DF subtends a total angle of, this was 40 and the other one is 20. So the total angle subtended by DF is 40 plus 20. And therefore, arc length DF will be 40 plus 20, all of it over 360 times 2 times 22/7 times 6370. You will notice, therefore, when the angles are from east to west, we are adding. Because what is most important to us is to see the total angle subtended by a given arc. All right, now going back to the same, let's now look at points G, H, and I. Points G, H, and I lie on a small circle or on the latitude 70 degrees north. And therefore, they are small circles. Because it is a small circle, then the radius will not be 6370. But we'll have to calculate the radius. Remember, the radius of any given small circle is R cos the latitude angle. So the radius of the small circle at 70 degrees latitude will be, let me write it as R70 will be 6370 cos the latitude angle. That becomes the radius of the small circle. So going back to the diagram, GH subtends an angle the same as the one that was here, because this is 40 and this is 0. So this angle here is 40 degrees. So GH subtends an angle 40. And therefore, arc length GH will be the angle it subtends, which is 40 over 360 times 2 times 22 over 7 times its radius, which is 6370 cos 70. Now, let's now look at arc length DG. Arc length DG. Arc length DG is an arc on a longitude, and the longitude is a great circle. The angle subtended by DG on the center is this angle here, this angle here, which this angle, DOG. And DOG, if the latitude is 70, then we said that the angle 70 is actually the angle measured from here to there. And therefore, DG subtends an angle of 70. Therefore, arc length DG will be the angle it subtends over 360 times 2 times 22 over 7. It's a great circle, so 6370. Let's look at arc length GC. Arc length GC. Arc length GC subtends an angle of all the way from here to here. It is this angle here up to C. Maybe I should draw another radius there. So this angle is 70 and this one is 80 because it lies on the 80 latitude. So the total angle subtended by GC is 70 plus 80. So GC or CG will be 70 plus 80 over 360 times 2 times 22 over 7 times 6370, because it is also on a great circle. And you can try as many as possible. I would want you to look at part B, C, D, and many others. What you need to understand is what is the angle subtended by the arc, and number 2 is the arc on a great circle or on a small circle. We'll stop at that and we'll continue in the next video. Thank you.